In this lesson, we will learn about Azure Virtual Network peering. First, we will find out why we need VNet peering. Then we learn about VNet peering characteristics and VNet peering configuration options. After that, we will configure VNet peering, and finally, we will conclude our lesson with the review questions. To understand about VNet peering, let's analyze this network. As you can see in this network, we created three different VNets. The first one is ITL-EUS-VNet01, and it is assigned with the address space 10.1.0.0/16. And this is a production VNet, and in this VNet we created one subnet. It is VM-prod-snet01. The second VNet is ITL-EUS-VNet02, and it is assigned with the address space 10.2.0.0/16, and this is the QA VNet. In this VNet, we created two subnets. The first one is VM-QA-SNET01, and the second is VM-QA-SNET02. And the third VNet is ITL-WUS-VNet01, and it is assigned with the address space 10.11.0.0/16. And this is a development VNet. And in this VNet, we also created two subnets. The first one is VM-dev-SNET01, and the second is VM-dev-SNET02. Now let's pay attention to the network connections. As you know, VNets are built on top of the Microsoft Azure Backbone Global Network, which means there exists a physical connection between the two VNets. So in this network, there exists a physical connection between the QA and the development VNets, and there exists a physical connection between the production and the QA VNets, and there exists a physical connection between the production and the development VNets. However, there is no routing between the VNets, which prevent the VNets from communicating among each other. That is the reason why network traffic generated in a VNet stays within that VNet. So in this network, the servers in the production VNet and the server in the QA VNet and the server in the development VNet can only communicate with the servers in the same VNet, but cannot communicate with the servers in different VNets. The simplest and quickest ways to allow resources in one VNet to communicate with resources in a different VNet is to configure VNet peering. VNet peering sets up the routing between the two VNets via the Microsoft Azure Backbone Network connection. Therefore, traffic between paired VNets is private, low latency, and high bandwidth. So in this network, we can configure VNet peering between the QA and the development VNets, which allows the servers in the QA VNet to communicate with the servers in the development VNet. Similarly, we can configure VNet peering between the production VNet and the QA VNet, which allows the servers in the production VNet to communicate with the server in the QA VNet. Please note that Azure VNet peering is not transitive, as it only establishes a direct connectivity between two virtual networks but it doesn't inherently extend that connectivity across multiple peer networks. So in this network, with the current setup, the servers in the production VNet can communicate with the servers in the QA VNet, and the servers in the development VNet can communicate with the servers in the QA VNet, but the servers in the production VNet cannot communicate with servers in the development VNet. To enable the servers in the production VNet to communicate with the servers in the development VNet, we have to set up another VNet peering like this. Now let's pay attention to the location of each VNet. As you can see, the two VNets, ITL-EUS-VNet01 and ITL-EUS-VNet02 are in the same location, East US. However, the VNet ITL-WUS-VNet01 is in a different location, West US. When we configure VNet peering between the two VNets in the same regions, we call it regional VNet peering. And when we configure VNet peering between the two VNets in the different regions, we call it global VNet peering. Let's go through VNet peering configuration options. We have to configure this option on each direction. In this screenshot, we configure it on VNet2 to pair with VNet1. The first option is to allow VNet1 to access VNet2. This option allows to route one-way traffic from VNet1 to VNet2. To enable the traffic from VNet2 to VNet1, you must also configure the option allow VNet2 to access VNet1. The second option is to allow VNet1 to receive forwarded traffic from VNet2. Enable this setting only when VNet2 have an NBA that receives traffic from outside VNet2 that gets forwarded to VNet1. When this setting is enabled, it allows VNet1 to receive the traffic outside of VNet2, which gets forwarded to VNet1 by the NBA in VNet2. So this option is to control the traffic from an external network connected to the NBA in VNet2 to send to a destination in VNet1. For example, if we want to send a network packet from CPVDC01 to MAZP app01, the package will go like this. When this option is not enabled, then VNet1 will drop the packet. However, when this option is enabled, then VNet1 will accept the packet and forward it to MAZP app01 like this. Now, to allow the traffic from VNet1 to send to the external network connected to the NBA in VNet2, we must configure an UDR and attach it to the subnet of VNet1. The UDR instructs VNet1 to send the packets destined to the external network to the IP address of the NBA. The next option is to allow gateway or route server in VNet1 to forward traffic to VNet2. Enable this setting only when VNet1 has a gateway or route server. When this setting is enabled, it allows the gateway or route server in VNet1 to forward the traffic that is not originated from VNet1 to VNet 2. Technically, it allows the traffic like this. The last option is to enable VNet 1 to use VNet 2's remote gateway or route server. Enable this setting only when VNet 2 has a remote gateway and the setting allow gateway or route server in VNet 2 to forward traffic to VNet 1 enable. When this setting is enabled, it allows VNet 1 to use remote gateway or route server in VNet 2 to send the traffic to another network connected to VNet 2 via the gateway or route server. So technically, it allows the traffic like this. Let's configure VNet peering. First, we will configure VNet peering between EUS VNet 1 and EUS VNet 2. Then we will configure VNet peering between EUS VNet 2 and WUS VNet 1. As you can see, our network is simple. We do not have a gateway or a route server. So all we need to do is to select the first option, allow VNet 1 to access VNet 2 and allow VNet 2 to access VNet 1. Here we are in the MAZ app01. Let's open the command prompt and let's verify its IP address. And you can see it has the IP address 10.2.0.4. Now let's ping the server MAZP app01 at the IP address 10.1.0.4. As you can see, we have no reply. Now, after this, we will ping the server MAZD app01 at the address 10.11.0.4. Similarly, we do not have the reply. Now, let's configure VNet peering between EUS VNet 1 and EUS VNet 2, and we will configure it in both directions. To do that, we need to click on Virtual Networks, then open VNet 02. Then we scroll down and click on Peerings. Here we click on the Add button. And in the Remote Virtual Network, we type in the peering link name ITL-EUS-VNet02-peering, and we select the virtual network, which is EUS VNet 01. Then we keep the default option, which allow EUS VNet 01 to access EUS VNet 02. Then we scroll down to configure it for the other direction. So here in the local virtual network, in the peering link name, we type in the name ITL-EUS-VNet01 peering, and we keep the same first option to allow VNet 2 to access VNet 1. Then we click on the Add button. As you can see in VNet 02, it has a peering with the VNet 01 and is fully synchronized. Now let's click on the virtual networks and open VNet 01 and click on peerings. As you can see from VNet 1 peering with VNet 2, it is also fully synchronized. We log on to the server MAZQ app01 again. Let's open the command prompt. Now let's ping the server MAZP app01 at the address 10.1.0.4. As you can see, we have the reply because the VNet peering between EOS VNet 01 and EOS VNet 02 has been set up and fully synchronized. Now let's ping the server MAZD app01 at the address 10.11.0.4, and as you can see, we get the timeout because we have not set up the VNet peering between the two VNets. So we have just configured regional VNet peering between EOS VNet 01 and EOS VNet 02, and we was able to verify it was working properly. Let's configure the VNet peering between EOS VNet 02 and WEOS VNet 01, and this time we will configure global VNet peering because the two VNets are in the different regions. To do that, we need to click on the Add button, and we will type in the peering link name ITL-EOS-VNet02 peering in the remote virtual network, and we select the virtual network, which is ITL-WEOS-VNet01. Then we scroll down and we keep the default option to allow WEOS VNet01 to access EOS VNet02. Then we scroll down, and in the local virtual network, we type in the peering link name ITL-WEOS-VNet01 peering, and we keep the first option, allow EOS VNet02 to access WEOS VNet01. Then we click on the Add button. As you can see, it is completed, and the VNet peering between VNet02 and WEOS VNet01 is fully synchronized. Let's click on the virtual networks, and we open WEOS VNet01. Then we scroll down and click on peerings, and as you can see, the VNet peering between WEOS VNet01 and EOS VNet02 is fully synchronized. Here we are in MAZQ app01. Let's open the command prompt, and we ping the dev server MAZD app01 at the IP 10.11.0.4, and we get a reply. Now let's ping the production server MAZP app01 at the address 10.1.0.4, and we get the replies. Everything looks good. We have just configured VNet peering between EOS VNet01 and EOS VNet02, and we also configure the VNet peering between EOS VNet02 and WEOS VNet01. And if the VNet peering is transitive, then we will have a connectivity between WEOS VNet01 and EOS VNet01 via EOS VNet02. However, VNet peering is not transitive, which means there's no connectivity between WEOS VNet01 and EOS VNet01. To prove that, we will log into the server MAZD app01. Then we will ping the server MAZQ app01, and we see the connectivity. However, when we ping the server MAZD app01 to the server MAZP app01, we will see no connectivity. Here we are in the server MAZD app01. Let's open the command prompt. As you can see, it has the IP address 10.11.0.4. Now let's ping the server MAZQ app01 at the IP 10.2.0.4. As you can see, we got the reply because the VNet peering has been set up between EOS VNet02 and WEOS VNet01. Now let's ping the server MAZP app01 at the IP 10.1.0.4. As you can see, we got request timeout because the VNet peering between EOS VNet01 and WEOS VNet01 has not been set up, and the VNet peering is not transitive. Let's conclude our lesson with the review questions.